Hi everyone, and thanks for joining us today. My name's Hunter, and I have the pleasure of welcoming you all to this Cognite product tour. For those joining the product tour for the first time, Cognite is a globally recognized industrial data and AI company that provides companies with simple, trustworthy, and contextualized access to their data and insights, driving full-scale digital transformation and AI initiatives. Our unique combination of a trustworthy data foundation, low-code AI agents, and industrial expertise enables energy, manufacturing, renewable, pharmaceutical, and other industrial organizations to scale AI initiatives across the enterprise. We expect that these will generate over $1 billion per year in value for our existing customers across operational productivity, process optimization, asset reliability, and much, much more. And we're delivering this by supercharging users across departments and domains with technology and tools that accelerate their transformation initiatives. Ultimately, digital teams need a scalable platform to deliver business impact from site to site. Industrial experts need AI-driven insights to expedite their workflows, and data managers need observability and governance to build trust in data that drives everyday decisions. During the product tour today, we'll discuss the current state of the industrial AI landscape and illustrate why context is not only important, but paramount to scaling AI-powered workflows. Our customers will also share some of their inspiring and real-world stories, showcasing the value of Cognite Data Fusion, our industrial data and AI platform, and Cognite Atlas AI, our low-code industrial agent workbench. These aren't ideas on slides. These are proven use cases delivering measurable impact, generating millions in cost savings and gains in operational efficiencies. For the Cognite demo, my colleagues in Phoenix, Oslo, and Austin will showcase the interactive user experiences of working with contextualized data and how this experience is being further elevated through the use of industrial AI agents, making it even easier to access contextualized data in seconds, streamline operational workflows, and scale this impact across teams and sites. You're going to see key contextualization capabilities in action, turning previously siloed data into one powerful, unified experience. Finally, you can submit your questions, follow-up ideas, and thoughts now and after the event on our customer community, Cognite Hub, which you can find at hub.cognite.com. With that, let's get started. Despite the digital transformational efforts that have been ongoing for years, we still hear from operators worldwide. Look, I have more data than I know what to do with, and when something breaks, my team still has to dig through dozens of disconnected systems and piles of paperwork to figure out what's going on. Data is supposed to deliver faster and more accurate decision-making, yet that's the paradox we see over and over. Industrial businesses continue to drown in data and starve for context and insight. Meanwhile, we're living in a moment of massive promise for artificial intelligence, and it's evolving faster and faster every day. And now, we're racing into the next frontier, industrial AI. While industrial AI is rapidly building momentum, many are still seeking to understand how it's going to deliver scalable business value. Industrial AI is not a generative AI copilot that can summarize documents or another siloed application for anomaly detection. This is AI that understands your operations. Industrial AI covers the complete AI value chain, from building a strong data foundation to automating tasks with AI agents. By implementing industrial data operations practices, organizations can effectively manage their data and scale industrial AI solutions to enhance decision-making, optimize complex processes, and automate workflows. This approach will fundamentally change how organizations run their operations. This sounds promising, but if your data isn't easily accessible for your people, your AI initiatives will face the exact same challenge. Many industrial AI initiatives are struggling to deliver measurable business impact today, and even fewer have successfully scaled. The reason is surprisingly simple. Data without context does not scale, and neither does AI. Energy, manufacturing, and other asset-heavy industries are rich with data. You have operational data in historians, engineering data, in files and PDFs, IT data, and ERP systems. None of it is the same type. None of it has the same nomenclature. None of it was designed to work together. So when you feed that fragmented data into AI, The results are frustrating. It's hallucinations, rework, unreliable answers. No one trusts it and no one uses it. That's why it's not just about innovative AI models or even having more industrial data, it's about contextualization. Contextualization harmonizes industrial data. Linking data across time, space, and systems, it connects time series to equipment, equipment to documents, and documents to work orders. It provides AI context. This temperature spike came from that sensor on that pump in that process line with this maintenance history. It creates a shared language and a shared map. Suddenly, AI doesn't see fragmented data, it sees a system. It knows where to look, what to compare, and what matters. Now, take this one step forward and add an industrial AI agent that identifies anomalies, suggests where to prioritize improvements, and estimates ROI of each initiative, turning insight into strategic action. That's why many companies are focusing on their foundation, creating an intelligent layer that understands their operations and business. It's what allows AI to go from theoretical to practical. Now, industrial AI stops being a science project. With a trusted foundation, industrial AI agents can analyze, recommend, and act with confidence. You're not building one-off use cases, you're building a system that learns and scales. A system that is understood by both your people and AI. In short, context is no longer a luxury. It's what turns disconnected data, hundreds of isolated solutions, and stalled POCs into real transformation. This is the era of contextualization.
Hello, my name is Liz Brenner, and I'm a design system lead at Cognite. We know from analysts like Gartner, Forrester, and Verdantix that industrial workers spend anywhere from 35 to over 60% of their time just trying to find the data they need to do their jobs. In some cases, that number can be as high as 90% when including data preparation, governance, and search. This inefficiency isn't just frustrating, it has a direct impact on production targets, safety, downtime. We see the same challenge when it comes to industrial AI. A lot of companies have started experimenting with co-pilots and chat interfaces, but the impact of these solutions is limited unless they drive action. We believe there's an opportunity for a much bigger shift, where AI can become a trusted advisor to redefine your operational workflows. At Cognite, we've been providing our customers with simple access to complex industrial data through Cognite Data Fusion. And now, with our new generation of industrial agents powered by Cognite Atlas AI, our customers are going even further, accelerating workflows, cutting through complexity, and getting straight to insight and action. So let's take a look at how this works right inside the product. Let's get started by opening our Industrial Canvas, an interactive collaborative workspace to showcase how operators, domain experts, and field workers work with AI agents to perform specific tasks. Although we will be accessing our AI agents through the canvas, it's important to note that any agent built with Atlas AI is accessible in other Cognite Data Fusion applications, as well as third-party applications through the Atlas API. But more on this later. The data exploration agent allows us to seamlessly find information, and in this case, add it to our canvas. We no longer need to search for this asset manually. Relying on the agent streamlines the process by saving us time and effort while allowing us to still verify the data. By using AI agents, I no longer need to know every ID of every equipment and can access the relevant information by simply describing it to the agent. This emphasizes the importance of contextualization. I can even use AI to summarize the operator manual. Now that we have our data, let's switch to our troubleshooting agent, which can be used by operations, maintenance, or engineers to help troubleshoot issues. After reviewing the data, I see there's an issue with the oil discharge. I'll ask the agent to help me troubleshoot the problem. The troubleshooting agent will only use data associated with this piece of equipment to perform the task, so I have full confidence that the responses are tailored to this specific equipment. The agent can take this one step further and create a cause map to better understand the various failure modes. Again, I can choose to define specific standards or documentation I want the agent to use. The agent is now asking us if we'd like to troubleshoot the potential causes. Let's go ahead and respond. We can see that the agent has not only given us a detailed write-up, but also provided the relevant time series to help us better assess the situation. And it looks like the recommended oil viscosity should be between 90 and 110, but the latest data shows an excess, and the agent is recommending we replace the oil. Let's go ahead and add this time series to the canvas. The agent is also suggesting to create a work order. I'll go ahead and review the proposed work. We can see that while creating the order, the agent has flagged that we are missing the required material needed to carry out the task and has gone ahead and placed the order for it. As a result, the agent has automatically pushed the maintenance schedule by 10 days to allow enough time for the material to arrive. This is just one example of how the agent doesn't just make suggestions, they take action, saving time and streamlining our workflow. I can confirm once more that this looks good and ask the agent to submit the order, which will send the information back to our source system. Because we are using these agents in our collaborative canvas, I can tag my colleagues so they are notified of the work. These are just two of our out-of-the-box industrial AI agents that can work alongside your teams, enhancing human judgment and speeding up execution. Every agent is built to use contextualized industrial data and LLMs to complete specific tasks. We are continuing to add out-of-the-box agents for common tasks, which can also be tailored to your specific needs. Additionally, you can build new agents in Cognite Atlas AI to further automate processes and move towards agentic workflows. Now, let's hear from our next customer, who will showcase how industrial agents can significantly shorten root cause analysis, reducing the process from days to just a few hours.
Hello everyone, my name is Alexandra Kresider and I'm a Senior Principal Maintenance and Digital Specialist in Cognite. And today I have with me Turanne Amdal, who is Aker BP Reliability Engineer. And he will share with us on how we work together to develop and also configure the AI agents to support this really lengthy and cumbersome root cause analysis today. To add to that, Cognite is committed to Aker BP need to continue innovating and also realizing value from that innovation. So we have been working together to really push the boundaries on what it means to make the generative AI to work for industrial assets. And as you probably may know, this is not a trivial challenge. And we needed to combine Aker BP domain knowledge and also Cognite industry-built technology. And we have created agents designed to streamline these complex workflows and accelerate the time to resolution and value, and then scale it to other assets. And you're probably all curious now on how it looks like, and we're going to show this today as well. But before we do that, Turanne, could I ask you to tell us a little bit more about your role and also the context on why Aker BP decided to use Cognite Data Fusion and industrial agents to streamlining this root cause analysis processes in the first place?
Thank you, Alexandra. My name is Turanne. I currently work as a reliability engineer in Aker BP, where I'm leading a team that perform complex root cause analysis for our assets. The traditional way of performing these root cause analysis are both time and resource consuming. And that's why we started exploring methods to make this process more efficient by utilizing an AI solution. This also aligned with the Aker BP strategy related to digital innovation and AI to enhance decision-making at every level of the organization. One of our main goals with introducing agents in root cause analysis is improving efficiency and or both in how quickly we identify issues and how effectively we respond. And by speeding up and enhancing our ability to understand the root cause of problems, we're able to make faster, smarter decisions. That means that we can shift from reactive firefighting to more proactive handling, where we minimize unplanned downtime, mitigate risks earlier, and ultimately reduce operational costs across the business. The key challenge we're facing is increased operational reliability on our assets. Our existing processes just weren't built to scale with the frequency and complexity of root cause analysis required to achieve this goal. Data gathering was also one of our biggest pain points. When working with root cause analysis, we had to pull information from several sources like PI and SIP, and had to try locating inspection, maintenance reports scattered across SharePoint sites. And on top of that, it's difficult to collaborate across disciplines in our existing tools, which slow down our ability to align on findings and to take decisive actions quickly. We've tried using different kind of AI tools, but quickly identified that this wasn't sufficient. We needed to use contextualized intelligence. In this industrial operation, it's not enough just to have the data. You need to have the right data in the right context at the right time. That's what enables precise and reliable answers and helps us move faster toward decisions. That's why we chose to engage Cognite for AI support RCA workflows. We tested different solutions before entering the collaboration with Cognite and quickly realized that Cognite could deliver in accordance with our need. So let's move on to the demo where we show how we use the AI solution for gathering and analyzing different types of data for our root cause analysis. In this case, we're conducting a root cause analysis related to an oil export pump, which has been experiencing recurring mechanical seal failures. What you see on the screen is a summary of an historical RCA where that was performed due to repeatable failures of an oil export pump. The direct cause of failure was contamination. The root cause was found to be insufficient communication of available data during design phase, in addition to limited capacity to analyze and manage mechanical seal issues during operation. To kick this off, we start from locating the specific pump data in Canvas and instruct the RCA agent to find related documentation like PNIDs, operation and maintenance manuals, data sheets, etc. The agent instantly retrieves these documents and adds them to the Canvas workspace alongside smart PNIDs, creating an interactive equipment overview. These data normally resides across at least 10 different systems, so it's much easier for us in the Canvas. Further, we look at time series data like suction and discharge pressure to understand the pump's current and historical performance. The agent automatically finds and visualizes the related data. We then continue by searching for a failure history, and the agent retrieves the information from SAP. The agent pulls this data without needing to log into SAP, saving time and providing simple access to relevant information. In addition, the agent analyzes the details in long text and description to filter only those work orders relevant for mechanical seal issues and leakages. This step normally requires a lot of manual work, so this feature saves a significant amount of time. We ask the agent to locate the failure notifications associated with the pump and look for references to mechanical seal issues. Relevant notifications are added to Canvas to enrich the insights to our analysis. And failure notifications are currently not given much attention in the RCA process due to the effort to analyze them is too high. And we don't have an out-of-the-box cause map or failure mode until this agent gave us this possibility. Here you can see the agent generating the cause map based on failure mode analysis and reliability templates. Agent confirms that the most common failure mode is internal leakage and generates the cause map for it with the list of most likely failure mechanisms and root causes. The solution provides us with the opportunity to manually adjust the cause map to identified failure modes that has not already been captured. The agent may also be used for identifying and analyzing images. The agent reviews historical work orders and identify images, searching for visual evidence of contamination. Using the agent to extract contamination details from work orders is highly efficient, especially for large image sets. In this case, contamination was confirmed, allowing the user to mark it as resolved and continue to analyze other failure mechanisms. An important step in every RCA is to evaluate current and historical operating conditions, which is a step that typically is performed by system experts. So we asked the time series agent to pull 10 years of historical data and calculate averages for both suction and discharge pressures. The agent quickly checks these values against its fine operating conditions. We see now that both suction and discharge pressures are analyzed, and the discharge pressure is currently below the operating limit as per design. This suggests that while the system is operating within safe boundaries, it's worth setting up monitoring for any future deviations. Apart from the technical finding, it's worth highlighting that with this agent, the reliability engineers can perform this time series analysis themselves without being system experts, thanks to on-demand access to real-time data. In the demo, you've seen both the functionality and the capabilities of the AI solution. It's promising because we have verified that it finds information quickly, it makes searching for data more efficiently, and it spotlights the information that we require to do root cause analysis. In addition, the team that I work with can make better and more confident decisions when we have easy access to trusted real-time information. So the ultimate goal is to use this solution to increase mean time to failure on our brownfield assets. So going forward, that's to move or to implement solution in a production environment, to upscale it, and to continue refining the AI agents to ensure that they help us to further improve our RCA workflows. And we're excited to continue collaborating with Cognite to further develop these industrial AIs in complex environments.
Fantastic. And thank you very much for sharing, Tor Arne, and the demo and the presentation. I think it's a really interesting insights and coming from that work. And I just want to add, it was fantastic, has been fantastic collaboration together with you and the larger maintenance reliability team, as well as the data science team. We need all of us together on that. And we are looking forward to continue innovation, but most importantly, to operationalize those industrial agents in operations, because this is the time to take out the value. So we will keep you all updated and stay tuned.
Hi, I'm Cameron Greenberg. I'm a senior product manager here at Cognite. As you can see, industrial agents can serve as trusted experts to support your team in executing different types of industrial workflows and accelerate time to resolution and value. Now, I'd like to take you behind the scenes for a few moments to show you how easy it is to build and configure these tailored agents using the Cognite Atlas AI Workbench. I'm going to walk through how Atlas AI uses contextualized data and best-in-class language models to create agents that speak your operational language, understand your industrial use cases, and are purpose-built to solve complex, industry-specific tasks. Let's dive in. We'll begin right here in Canvas, where Liz left off earlier. I've been mentioned here and asked to take a deeper look at the gas inlet temperature for the first stage compressor. You can see I've added a specification sheet containing normal operating ranges among other critical data, which I want to use in my analysis. I'll show you how we can continue into charts and have an agent seamlessly leverage the data from this specification sheet as we perform more advanced analysis. To do this, let's first dive into the Atlas AI Workbench, our low-code environment for building and tailoring agents, to show you how easy it is to configure an agent with instructions, data, and tools to tackle this. This is my personal dashboard, showing the agents I've created for various industrial tasks. You can easily get started by creating an agent from a template, pick up where you left off with an existing agent, or start from scratch. Let's jump into my charts troubleshooting agent I already started. I want to update its ability to retrieve relevant design specifications when analyzing time series data. This is the agent builder interface. The left side is where we configure agents, and the right side we have a live preview to test and tune behavior on the fly. I'll show you that in a moment. In the general section, I define the agent's name and description, making it easy for users to understand its capabilities and purpose. I can also add sample questions, which help make it easier to get started. In the prompting section, I can select from best-in-class language models to power my agent, and more importantly, I can add instructions to define the agent's behavior. For example, I've instructed this agent when I ask about time series analysis and exceeding design limits to locate the specified asset, find the relevant specification sheet, extract the design limits, and then perform the analysis using those limits. Of course, to carry out these tasks, the agent needs access to the right data and tools.
I already have it configured with tools for time series analysis, which enables the agent to write and execute code, and a tool for retrieving asset information from the knowledge graph. But Atlas AI offers many more capabilities. We have a growing toolbox of pre-built tools specifically designed for industrial use cases, data retrieval, document analysis, code execution, and more. These tools are designed to work seamlessly with each other and with your data in Cognite Data Fusion. Let's go ahead and add the Find Files and Ask Document tools. Find Files enables the agent to retrieve documents like specification sheets, manuals, engineering diagrams, etc. Ask Documents then applies semantic search to extract meaningful answers from those documents. Both tools are designed to work well with little configuration. Now, let's do a quick test here in preview, and let's see if it can retrieve the design specifications we're looking for. I'll ask if it can find the normal operating range for the first stage compressor asset. And while the agent is working, it's reasoning over my question to determine which tools to use and in which sequence to give me the best answer. This is where the value of an agent comes through. It's not just retrieving data. It's making smart decisions about how to solve industrial tasks. It looks like it accurately retrieved the normal operating range, and we can see exactly where it got the information. This shows that our new tools are working perfectly. Now, let's publish our changes. And just like that, the agent's now grounded in our industrial data and available to use across Cognite applications, including charts. Now that it's configured, let's see it in action. Jumping over into charts, here I'm looking at the inlet temperature for the first stage compressor, which I was asked to investigate earlier. Let's get some help from the agent we just configured. I can quickly search and open it up. I'll ask it to perform a deviation analysis against the normal operating range defined in the specification sheet. As the agent runs, it's reasoning over my question, retrieving relevant time series as well as documents, using semantic search to extract insights, and it's writing necessary code to deliver the analysis. And because every step is visible, I can verify that it found the right asset, retrieved the proper spec sheet, and extracted the correct limits, and used those limits when it produced its analysis. Atlas agents make advanced analysis accessible directly within charts, surfacing valuable insight without me needing to write a single line of code. This agent, like others, is now available to the entire team. With the Atlas AI Workbench, teams can easily build and tailor agents to fit their own workflows and use cases. And because everything is grounded in contextualized data from Cognite Data Fusion, you can automate and solve real industrial challenges reliably at scale.
This was just one example of how you can create and enrich agents with Atlas AI, delivering solutions tailored for your specific workflows and use cases across your operations. Access to contextualized data in your industrial knowledge graph allows these agents to deliver a trusted and tailored experience. It's contextualization that's the foundation that allows these agents to reason across complex, real-world data, to execute domain-specific tasks, and automate industrial workflows. With this in mind, we're going to hear two more customer stories highlighting how Cognite Data Fusion provides their organization a scalable foundation to optimize performance, lower operational costs, and increase efficiency.
Hi, my name is Mami Kubota, and I am one of the project owner for the maintenance strategy group at Cosmo Oil. Cosmo Oil is one of the biggest Japanese petrochemical companies and is part of Cosmo Energy Group. We are committed to our public mission of providing essential energy and chemical materials safely and reliably for everyday life. While our core operations remain in petroleum and petrochemicals, the company is proactively responding to long-term environmental shifts by expanding into renewable energy. In my current role, I am leading an initiative to enhance the implementation of collaborative maintenance at Cosmo Oil. One of our business operational objectives is to continue driving preventive maintenance at our facilities, so our maintenance experts can resolve challenges quicker and prevent potential breakdowns before they occur and negatively impact our operations. We believe in taking advantage of available technologies, such as implementing digital twins to perform efficient remote monitoring, enable collaborative maintenance planning and execution across refineries, and enhance the overall operational efficiency of our critical assets. By making our maintenance activities more efficient, we believe we can reduce downtime and unlock greater equipment reliability, which are both critical to drive operational performance and business outcomes. One of our pain points was that the crucial maintenance information, such as Excel files, PDFs, text documents, paper maintenance records, and reports, was scattered across various sources, and our engineers had to spend 70 to 80% of their time collecting data from these disparate sources. This inefficient data collection process hindered their ability to make faster decisions and bring critical solutions to improve the state of maintenance processes. To overcome these challenges, we recognize the need to maximize the productivity of our engineers and maintenance experts. For us, that started with solving the data problem. It was not just about bringing information together efficiently, it was also about empowering our teams to extract insight from data quickly. Our vision was to unify our refineries in a singular virtual space by leveraging digital twin technology. We started to work with Cognite and their industrial data and AI platform, Cognite Data Fusion. We realized that this partnership would allow us not only to bring all the necessary information together, but to connect and integrate million maintenance data points and record it in the most streamlined way. It would also enable us to contextualize that data and build a dynamic digital twin where all maintenance information and insights are immediately available to plant workers. Now, let me show how Cognite helps transform our maintenance operations and increase the productivity of our experts. Here, you can see the refinery equipment. Cognite Data Fusion's AI capabilities can automatically recognize tag data, allowing for the swift execution of data construction. Our engineers used to spend 1 to 2 hours a day in the field formulating construction plans. Now, it only takes about 10 minutes at their desk, which saves me a lot of time and a trip to the field. The use of Cognite Data Fusion in building a digital twin enables the realization of collaborative maintenance, leading to increased efficiencies, improved working conditions, and maximized productivity across engineers' teams. By visualizing historical data in charts, Cosmo Oil's maintenance teams can analyze trends and identify potential degradation or failure patterns in their equipment. This enables them to move toward predictive maintenance, anticipating issues before they occur and scheduling maintenance proactively. An example is vibration sensor for a rotating machine. Cosmo's unique approach has created a dashboard dedicated to monitoring the condition of rotating machines. Sensor information installed on rotating machine in the field is imported into CDF and can be time series to monitor trends. Each rotating machine has vibration threshold, and rotating machines that exceed the threshold are alerted, allowing engineers to see them immediately. If you want to compare and visualize the equipment operation data for more detailed analysis, charts can be easily created from the dashboard screen. We are also trying to use AI to predict future vibrations. Currently, in the data collection stage to improve accuracy. The image is like the green line, where AI calculates prediction based on past result. And we hope to able to predict the date and time when the threshold value will be reached. This would allow us to move to predictive maintenance and plan maintenance in advance, predicting problems before they occur. It would be great to highlight here as well that because of data being contextualized and that data was put into an understandable data model, also known as a knowledge map of Cosmo oil site information. This unlocks the ability allows charts to easily pull information. We need to derive actionable insight and quickly investigate an issue, share it with team, which leads to effective collaboration and data-driven decision-making between the maintenance operations team. Now we have interactive P&IDs, which provides a dynamic and user-friendly way to navigate the complex systems within Cosmo Oil's refineries. Unlike static drawings, these interactive diagrams let users zoom into specific areas, click on equipment symbols to instantly access real-time data, historical trends, maintenance records, and other related information, all directly within the diagrams. This significantly improves the speed and ease of finding critical information, as you can see. Interactive P&IDs can be integrated or linked to maintenance management systems. When planning or executing maintenance tasks, technicians can easily locate relevant equipment on the P&ID, access its maintenance history, view associated procedure, and even update work order statuses directly from the diagram. This streamlines workflows, reduces the risk of errors, and improves communication between operations and maintenance teams. By sharing data in real time through Cognite Data Fusion, we have established a system that enables stakeholders to respond quickly and effectively. We are excited to continue working with Cognite to further enhance our maintenance operations through digital twin and Cognite industrial tools. With our high-quality contextualized data as a strong foundation, we were also eager to embed generative AI workflow to accelerate time to value, achieve our goals, and make our business even safer, more sustainable, more profitable, and more efficient.
Hi, my name is Lisa and I work as a process engineer at Moelven. In my role, I work with improvement based on process data with focus on energy. Moelven is a leading Scandinavian industrial group focused on sustainable wood-based building products and systems for the construction industry. With over 100 years of experience and operations across Norway and Sweden, Moelven delivers high-quality timber around the world to meet the needs of a modern building project. Sustainability is central to how we work. Our raw materials come from certified Norwegian and Swedish forests, and we're constantly investing in reducing our climate footprint. Our mills are in the same forest we harvest, and our driving mission is to enable a smarter, more responsible way to build the future. One of our main goals is to use data to improve how we operate. A big part of this is building a strong data foundation to support better reporting and energy monitoring. Sawing and drying timber uses a lot of energy, so being able to track and reduce the consumption is a good start on our way to meet our sustainability targets. With Cognite, we're aiming to get much more detailed insight in where and how we can work with improvement on our sites, so we can act faster and make smarter decisions. Our sawmills are spread across Sweden and Norway, and each site has its own system and way of working with data. This has created a complex mix of old and new systems that don't talk to each other. Connecting them in the standard way has been constantly challenging. We often had to spend hours just to finding or verifying the right data, which slowed us down and made it hard to share insights or scale solutions across sites. Without the common setup, it was tough to get a clear, trusted view of what was really happening in the production. The way we worked earlier was to collect the data from scratch. You had to go out to the machine, print it out, take the report on paper, and just click it into Excel or something and make it manually. And that we had one person at this site who did this 3 hours a day. And now he doesn't. Now he can work with the data. In this particular way, we have every calculation is in Cognite, and then make it very easy for us to use like Power BI or Grafana or something that we find usable at the moment. With Cognite Division, we can also read meters that we don't see that we need to switch right now to digitals. We can just use that we have. It's not have to be a big investment to get the data out. You just take the camera and put it there, and then you have the Cognite Data Vision to do it for you. And now we will look at an example of how it looks like when we're working with Cognite Data Fusion at Moelven. So here we have the first page that's from the saw line. We work in orders. So the big goal here was to connect all the data to one order from all the systems. So to make it look good, we had to make one report for each system, but the main goal is to follow our order. If we look at the saw line, we have like several of reports. And when we want to look at the yield, we have to filter. We want to filter on and look at the same historical orders. And this is how we work with improvement based on order. And then we have the log information, volume information. We have green sort, dry sort, and everything has their own. And in the total end, we have something called measurement control. And that's the traceability part. Here we have connected all the meshing groups to the whole to one order, so we can follow the order through the whole process. We have made the energy report. So as I said earlier, we had the product monitoring as a base, and on top of it, we have the layer with energy. And this one we can use in every sawmill that we have. We have the thermal energy, we have the electric energy, and how much we have been producing, and some key performance index that we want to follow. The standard that we built behind the energy data, we built the asset structure, the asset hierarchy. You can easily take this energy report and scale it to other sites, because we have the same like saw line, dry sort, green sort, and we have named the energy meters in a standard way, so we can use the same functions and just scale it out. So here we have consumption for each order in every part of our production area. We have everything from the start. We have the log sort, saw line, green sort, and dry sort. Here we have the information from the log measurement system. We have the saw, and we have also the green sort system. They didn't talk to each other for reporting before. We have drying kilns, their own system, and we have dry sort. And yeah, that's it. All those systems now talk to each other in one report. So we also see in the drying kiln, we can see the result from the drying kiln, and we can see the connection that we have built. That's totally automatically now in Cognite. So we get a match to the right dry sort, and we see also the result from the dry sort connected to each other. And in the end, we see everything in one. Everything we need to follow to make improvement based on measurement in one dashboard. And that's totally new. This is very useful for us because they save us lots of time for the collecting part and make that big Excel report that we made earlier. All the time that we spend on that one is now time that we can use for real maintenance or real improvement work. This use case has been a great example of how having contextualized high-quality data can make a real difference in how we operate. With Cognite Data Fusion, we're not just collecting data, we're giving it meaning. That context is what makes it possible to build scalable, impactful solutions like our product monitoring report and energy report. Now we will be able to scale it out even faster to our sites. The feedback from our team has been really positive. They appreciate having faster, easier access to data they can trust. Now we get much more accurate data from our energy meters. Before, someone had to check the meters manually once a month, write the numbers down and enter them to Excel. It was a slow and time-consuming process. Today, the entire process is fully automated using Cognite Vision. It's a huge improvement both in terms of efficiency and data quality. Looking ahead, we're excited about scaling our work into new use cases like drying optimization, real-time quality monitoring, and even AI-based insights to support decision-making. But we know that to succeed with AI and agentic workflows, we need to get the data foundation right. And that means continuing to invest in contextualized, connected, standardized data. That's why this partnership with Cognite is so important for us, not just for what we're doing right now, but also for the future. Thank you for listening to me.
Hi, I'm Joyce Shi, and I'm a senior software engineer here at Cognite. So far, we've shown you what's possible with contextualized data and why it matters for industrial AI. Now it's time to show you how contextualization happens. Scaling industrial AI requires a robust data foundation where data can be reused, enriched, and applied across many use cases, whether your objective is to optimize production, reduce downtime, or increase efficiency. So let's jump into Cognite Data Fusion and explore the powerful data management and contextualization capabilities and see how to transform raw, fragmented industrial data into a unified, contextualized, and scalable foundation.
From Liz and Cam, you've already seen how powerful AI can be in our Canvas and Charts applications. But how does this data get into Cognite Data Fusion? With over 100 pre-built extractors, you can onboard your data quickly, no matter what system you're running or how complex your data is. We provide out-of-the-box integrations with systems like Aviva Pi, SAP, and a wide range of historians, ERPs, and EAMs. Once we have connected to our data sources, the next step is to create a data workflow where it is easy to build, inspect, and operate data pipelines at scale to get your data into Cognite Data Fusion. The newly released Data Workflows provides a unified experience to move, transform, and manage data in one intuitive user interface. With Data Workflows, users can link many different processing steps into one comprehensive job, delivering more observability and reducing data management efforts. Throughout the beta testing, we saw over 2,500 workflows created with more than 150,000 runs daily, and we're happy to announce that Data Workflows is now generally available for all of our customers. Users can choose between different out-of-the-box task types to add to their workflow, or a functions task if you would like to write your own custom logic. We'll start by adding a transformations task that transforms data extracted from an identified source system. Next, we can add any pre- and post-processing tasks. For example, we will add a functions and CDF request task here. Finally, add the appropriate trigger to your workflow. When the identified event occurs, your workflow will begin. After your workflow runs, you'll be able to monitor its progress and view its results both in the Workflows product and when using our industrial search for more granular details, making it easy for you to track, monitor, and observe your workflow in action. Now that your data is available in Cognite Data Fusion, let's move over to see what powerful new contextualization capabilities we're working on. In our detailed diagram parsing application, we can start by running our automated parsing process on the PNID file that Liz showed earlier. During this parsing process, our application uses AI to detect text within your PNID and link it to relevant assets and files in your data. Notice that our AI-based algorithm has detected a link to the same first-stage compressor asset that Liz has shown earlier, so we verified this mapping to establish this relationship. Here in the orange, you can see the asset links that have been suggested by the AI. In the blue, you can see the asset links that have already undergone human verification. In addition, our detection algorithm also detects links to connecting files. We can continue to create these asset and file relationships. But Cognite Data Fusion doesn't just create relationships between documents and PNIDs. It also contextualizes the information within those documents. Let's take a look at another example of what kind of information we can extract from a high-quality vectorized PNID. Notice how our detection algorithm has identified the various symbols within the PNID. For example, this symbol as a check valve. In addition, our algorithm not only knows what the symbol represents, it also knows which other symbols it is connected to. Here we can see that the identified valve is connected to a pipe, which is then connected to a page connector, and so on and so forth. Using this foundational understanding of connections, our agents are not only able to identify and access data within a PNID document, but also systemically traverse it to unlock more powerful use cases. Just as before, we can also review suggestions for connected files and assets. We see here that this file is actually also connected to the same first stage compressor we saw earlier, so we verified that relationship as well. Another powerful contextualization capability is the document parser, which uses an out-of-the-box AI agent to extract information from documents and populate a pre-existing data model. Here, we have a data sheet for a first stage discharge cooler. Let's select the view that we've created for discharge coolers. Finally, let's start our parsing job. Notice how the document parser has extracted data from this data sheet based on the provided view. Here, you can review the extracted data and approve or reject its suggestions. Upon approval, the data will be added to your knowledge graph, further enriching your existing data. This gives our agents a more reliable knowledge base upon which you can unlock and build even more use cases. The contextualization services that we have demonstrated here today are made even more powerful when used together with data modeling. Let's take a look at how these tools can work together. Here, you can see your first data model, the core data model, a foundational out-of-the-box data model provided by Cognite. This serves as your starting point. Contextualization services such as detailed diagram parsing and document parser populate this data model. This is what creates the contextualized knowledge graph and connects your previously siloed data. Then, you can query this knowledge graph throughout all of Cognite Data Fusion, for example, with agents, applications like Industrial Canvas, and the Cognite Data Fusion API. But this data model is meant to be a starting point. Here you can see that we have many other data models as well. Together, these data models populated with your contextualized data is what forms the powerful interconnected knowledge graph, which allows you to unlock so many different and valuable use cases. Now, here in Canvas, I've added the different documents we've contextualized today. And even though we've explored different ways of contextualizing different types of data, you can see in Canvas how connected this data really is.
These were just a few examples of how Cognite Data Fusion transforms fragmented industrial data into a connected, contextualized, trustworthy foundation, creating meaningful relationships, building a comprehensive understanding of your operations, and powering intuitive user experiences in tools like Canvas and charts, enabling seamless integration with third-party systems, and making generative AI truly work for industry. Our platform brings together diverse industrial data sources, creating meaningful relationships and building a comprehensive understanding of your operations. With the contextualized data foundation in place, you're no longer reinventing the wheel for every use case. Instead, you're working from an intelligent map of your operations, creating data products that can be reshaped and reused across teams, tools, and workflows. Our contextualization capabilities turn standalone data into actionable knowledge, allowing teams to solve problems faster and scale solutions easily.
Thank you for joining us today and seeing how Cognite Data Fusion and Atlas AI are driving a fundamental shift in how industrial organizations operate and unlock the full potential of industrial AI. Cognite Data Fusion replaces fragile point solutions with a unified, scalable, and repeatable data backbone. It brings insights to all of your people in their day-to-day context. It also transforms the way industrial organizations approach critical use cases and deploy trustworthy industrial AI agents. This is what creates true interoperability and scalable transformation for your teams and your business. We're committed to an open, future-proof architecture that makes generative AI work for industry so you can achieve peak performance, lower operational costs, and realize millions of dollars in efficiency gains today. We have an exciting lineup of releases in 2025. In our June release, data and AI workflows for more simple and trustworthy data processes. In September, we're bringing Atlas AI's industrial agent building and deployment workspace from our early adopters to all of our clients. And lastly, rounding out the year with our December release, where we'll dramatically reduce the threshold of building the industrial knowledge graph to support AI use cases through a completely revamped experience, bringing SMEs into the process. Everything we release in 2025 and beyond is in service of bringing AI to all industrial users. Because the next wave of industrial transformation won't come from having more data. It will come from context that humans and industrial AI can trust and rely on, allowing them to rapidly build and deploy industrial solutions and workflows that change how they work and solve complex industrial cases. As we close, I'd invite you all to join us at Impact 2025, taking place this October in Houston, Texas. This year, we're making our Global Industrial Data and AI Conference even bigger, bringing together users, business leaders, digital teams, and data and AI innovators from around the world. You'll hear firsthand from industry leaders and take place in interactive, hands-on sessions that bring industrial data and AI to life. To learn more and take advantage of early bird pricing, scan the QR code on your screen and visit cognite.com. There, you can also find a wide array of industrial content about contextualization, industrial AI, and hear from more of our customers and their success stories. We also invite you to join our open user community, Cognite Hub, at hub.cognite.com. There, you can engage and participate in discussions with fellow industry visionaries, operators, and business leaders, as well as get the latest on product releases that we talked about earlier. Thank you again for joining our product tour. We look forward to connecting with you soon and supporting your journey toward an efficient, resilient, and sustainable industrial future powered by data and AI.